Okay, to me, the trickiest of the transformation things we do has to do with vertical and horizontal stretches and shrinks. And so what you have is a case where you're multiplying by something. And so if you think of f of x as your y values, okay, because that's what they are. F of x is your y values in a graph. Then if I multiply those y values, so a times f of x, if I multiply those y values by something bigger than 1, then that means that those y values will get bigger, which is a vertical stretch by a factor of whatever that number is. And so that's a case of like if I had like 2x squared would be a vertical stretch of 2. The 2 is multiplying our function, our original function x squared. Okay, so it's multiplying that function by that. If that number is a fraction instead, like if it was a half, then in that case I'm shrinking because I'm taking all of the values that x squared normally has and I'm halving them. Okay? Now, when they're inside, when the number's inside the function, so let's switch to square roots for funsies. So if I have like the square root of 2x, that 2 on the inside is actually going to bring all my x values in closer. Okay, that's what that 2 does. It brings my points in closer to the y-axis, which makes it a horizontal shrink, not by 2, but by a factor of a half. Whenever it's inside, this is kind of the same deal as whenever we're inside and we have a positive and we change it to a negative. Since it's inside, you know it's actually going to be the reciprocal, that you're shrinking by a half horizontally. So then if we had a half underneath, okay, if I'm multiplying my x values by a half as soon as I plug them in, that actually ends up moving things out, so that's actually a horizontal stretch by a factor of 1 over 1/2, which means you flip the 1/2 up and you get 2. So in these last two cases, you always look at the reciprocal of what's going on as far as like whatever you're saying what's happening. Now the example we have here, we're given a graph that's just a whole bunch of things thrown together, and there are quite a few points here that are labeled to help us, but let me label this point. I think that's the only like particular point that didn't get labeled. So we don't know what the formula for this function is. It doesn't really have an easy formula anyway. It would be a piecewise function. But we want to graph each of the following. So I'm going to start out with A, and I'm going to graph 2 times f of x. This green function is f of x. If I multiply all of my f of x values, all of my y values by 2, then what does that look like? Well, negative 5 comma 0, if I multiply the y value by 2, that's still 0. So these aren't going to look identical just because they don't actually have the same scale, but I think hopefully we'll still get a good idea. Negative 1, negative 4, if I multiply the y value by 2, that's negative 8. So negative 1, negative 8, 0, negative 2. I'm going to multiply the negative 2 by 2 and get negative 4. 1, 0 is going to stay at 1, 0 because 0 times 2 is still 0. 3, 4, that 4 is going to go up to 8. And then 5, 0 is going to stay. And so then we would connect those dots and try to make it look similar as far as like straight lines looking like straight lines and the parabola looking like a parabola. Okay, and so what happened was we took all our y values and we stretched them out away from the x-axis so that they were all twice as far away as they were before. Now B, we have 1/2 f of x. So now this is a horizontal, not a horizontal, a vertical shrink of a half. So instead of things getting farther away, they're actually going to get closer. So again, these points that are at 0 are not going to change. That have a y value of 0, they're not going to change. But like -1, -4 is going to move halfway in, so it's going to be at -2. 0, -2 is going to now be at -1. 3, 4 is now going to be at 3, 2. And so our graph ends up being squished quite a bit towards the, that's a parabola there that I need to draw curvy. Everything got squished closer to the x-axis. Now part C, remember we're inside now, so this is a horizontal shrink by a half. Because what's happening is we're affecting our x values, and anytime we affect our x values, it's the opposite of what you would think. Okay, so we're actually going to move our x values in halfway to the y-axis. So -5, 0 would be -2.5, 0. -1, -4 is going to be -1/2, -4. 0, -2 stays where it's at. 1, 0 becomes 1/2, 0. 3, 4 becomes 3/2, which is 1.5, 4. 5, 0 becomes 2.5, 0. And then we connect the dots. Okay, so that is a horizontal shrink by a half, so f of 2x. Now if we want to do f of 1/2 x, that is a vertical stretch, not a vertical, a horizontal stretch of 2. Okay, because it's inside, it's affecting x, that means it's a horizontal something, and it's the opposite of 1/2, which is 2. So all of these points are going to move out twice as much. So -5, 0 is going to be at -10, 0. -1, -4 will be at -2, -4. 0, -2 stays where it's at. 1, 0 goes to 2, 0. 3, 4 goes to 6, 4. And 5, 0 goes to 10, 0. Then we connect our dots. E is almost the exact same as D, but we have the negative thrown in here. Remember that with reflections, if we're making it negative on the inside, we're making x negative, that's a reflection across the the y-axis, because it's the opposite of what you would think. We're making x negative, so we reflect across the y-axis. So that means that I'm going to take this graph from D, where I've already stretched it by 2, and I'm going to reflect it. So this -10, 0 goes over here. -2, -4 goes to here. This stays the same. This goes to here. We have 6, 4 there. So now the parabola is on this side with our lines on this side. So see, it looks like a reflection.